says the angle of elevation to the top of the pole is 26 degrees and 40 minutes. The height, whole top. No. Now, anytime they're talking about an angle of elevation, they take like a flat plane like this, and then whatever, if you look up, that's called the angle of elevation. And if you look down, that's called the angle of depression. So you basically look straight out, and if you have to then lower your gaze, that's an angle of depression. If you have to raise your gaze, that's an angle of elevation. Okay, so we know that this is 26 degrees and 40 minutes. So first thing we're going to have to do is change over 46 degrees and 40 minutes. Anybody remember how to do that? How many minutes are in a degree?
60.
60. So we just need to know the decimal form of 40 out of 60.
40 over 60.
2/3, which is?
0.33. 66.
Mm-hmm. So this is 26.666, repeating, right? Degrees? I'll put here 26.66 degrees. I'm just going to go to the nearest hundredth. And it says we're supposed to find the height of the flagpole, so we want to find this over here. Okay, so I've got an angle. What's this side compared to that angle? That's the opposite side. Oh, this one. Adjacent. So what should we use? Tangent. Tan. Opposite over adjacent. Cross multiply. 1 times x is just x. The other side is 123 times the tangent of 26.66. Put it in your calculator. Make sure you get the same answer I do. Don't just assume that you're going to, because if your mode is messed up, you will not get the same answer. What is a reasonable height for a flagpole? 80?
61.7 feet.
Is that reasonable?
Yeah.
Yeah, I mean, definitely the one that you're looking at outside is not 61 feet tall, but
It's
it
like-
is possible.
It's like 40 something.
What's unreasonable? What's a stupid answer?
200
Are there
million.
200 million feet? That's very stupid.
0 feet.
0 feet.
1 foot. It's
1
like
foot.
1 foot.
Somebody's like, man, we just can't figure out how tall this flagpole is. It's a foot tall. We better go 123 feet away from it. Figure out the angle so that we can figure out how tall it is. Yep, this is a reasonable height. So, which is, what was it, 61 point something? 61.8 feet.
That's crazy. Wait, so when you put tangent 26.66 over 1, what were you doing there?
I'm cross multiplying. So tangent is equal to opposite over adjacent, and then I put it over 1 so that I could cross multiply to make it easy. So I'm doing 1 times x, which is x, and then tangent times that. Which, if you're like, well, then just always take the two things multiplied by each other. It doesn't always work that way. If the one you're trying to find is underneath, you're going to have to end up dividing. It's just way easier just to set up a proportion and look at it. Tanner? Oh, they used to make, so what your calculator is doing is actually, it's doing calculus. Yeah, it's finding the areas under curve. So when they didn't have calculators, they literally had books the size of this that had tangents of all kinds of different things that were calculated out by hand that they published then and wrote as like big textbooks that you could look things up. That's not horrible.
Yeah.
Let's never go to that time.
You ever need to do that?
No.
Well, like not that, like we don't need to write the test book, but like you have to like in college, like know how to solve like the tan and stuff like that.
If you're in calculus, I mean, they might talk briefly about where those numbers came from, but no, I don't think that you'll ever have to do that. Okay, I'm just grabbing a separate sheet of paper because my paper looks like this on the back side. Very annoying. Example 3. How are we doing? Does everybody feel confident so far?
Wait, is it first?
The math isn't worse. Like I said, the hardest part about these problems is getting the drawing right, and then you're pretty much home free. All right, let's try again. From the top of a 210-foot cliff, David observes that a lighthouse is 430 feet offshore. All right, so we got a cliff, and then there's like some ocean, and there's like a lighthouse. You can tell that that's a cliff because I wrote cliff on it. This cliff is what? 210 feet tall. And they know that this lighthouse is 430 feet offshore. And we need to find the angle of depression from the top of the cliff to the base of the lighthouse. Okay, this is a hard question. Where's the angle of depression? Mason,
Top left,
right here?
yes.
No. I know, isn't that crazy?
Angle of depression
Oh, is it
over
because there
there.
are angles?
Remember, yeah, angle is when you're looking straight out, and if you're depressing, you're going down. So it's the angle from you going straight out to the depressing. So actually, it's here. That's the angle of depression. It's how far, it's the angle at which you're looking down. So like you're looking straight out like this, right? And then you look down. So we will need this one to be able to find out what that one is.
Isn't that one equivalent to the one by the lighthouse?
Yes, that one is going to be equivalent right here because that's going to be like a parallelogram?
Yep.
Okay? So these are both going to be the same.
Okay, so we're pretty much just solving for that.
Sure, it's just alternate interior angles. The thing is that if you don't know what an angle of depression is and you automatically think, oh, I bet it's this top angle, then you're going to get it wrong.
Okay.
Okay. So, angle of depression. Ideas. Anybody have one?
Wait.
We're trying to find out.
Finding that one.
Yeah, we can just find this one.
Oh.
Sure. I mean, you could also, like, if you wanted to write as a parallelogram, you could write this as 210 and this is 430 up here, you know, like. So, finding this one or this one. You want to go for it, Thomas? Okay, are you doing like this imaginary triangle up here? Or you're doing the real triangle down there? Okay. So, what sides do we have?
We have adjacent and opposite.
Right, we have adjacent here and opposite over here. So, what are we going to use? So tangent theta equals opposite, which is 210 over 430, which is the adjacent. Now, should I put it over 1 and cross multiply? No, why?
Or we are.
I'm trying to find the angle, right?
Way inverse.
So we're going to use inverse tangent. So in our calculators, we're hitting second tangent, which gives you inverse tangent. And then in your calculator, you can just type it in, 210 divided by 430. About 26 degrees?
Sure.
Is that a reasonable answer for right there?
Sure.
I think so. What's an unreasonable answer? What's a stupid answer? 1 degree, 360, that's an extra stupid answer. 4,000 degrees, what are you doing? Okay, so